Good morning students, welcome back to 9th Science, Unit 13, Chemical Bonding, Part 2. Now what you learnt in the previous classes, let us recall. Introduction of chemical bond, Cauchy-Lewis approach to chemical bonds, octet rule, unstable electronic configuration, and Lewis dot structure. And in this class, we are going to see the topic, the types of chemical bond. Chemical bonds are classified into two, strong bond and weak bond. Strong bonds are classified into ionic bond, covalent bond, coordinate bond, metallic bond. And weak bond, it is classified into hydrogen bond, van der Waals interaction. In this class, only have to study about the strong bond, only three types of bond, ionic bond, covalent bond, coordinate bond. Other types of bond we will study in the higher classes. Depending on the types of a bond, they shows the different characteristics or properties. Ionic bond or electrovalent bond. What is an ionic bond? Ionic bond is a chemical bond. What is a chemical bond means? It is a force of attraction between the atoms that holds the atoms together to form a molecule. So, ionic bond is a chemical bond formed by the electrostatic attraction between positive and negative ions, plus and minus ions. The bond is formed between two atoms when one or more electrons are transferred from the valence shell of one atom to the valence shell of the other atom. So, the atom that loses electron will form a cation, that is a positive ion, and the atom that gains the electron will form an anion. Negative ion means minus ion. Now, the force of attraction between the positive and the negative ion that holds the atom together to form a molecule. The oppositively charged ions, the plus and minus ion, comes closer to each other due to the electrostatic force between the two oppositively ions, plus and minus ions. In between the force is called as what? Electrostatic force of attraction, and thus they form a ionic bond. As the bond between the ions, plus and minus ions, it is called as ionic bond, and this attractive force is being electrostatic, so the bond is also called as electrostatic bond. Since the valence concept, the valence shell means last shell, contains the electron, explained in terms of electrons, it is called as electrovalent bond. So, this bond is called as ionic bond or electrostatic bond or electrovalent bond. Now, the formation of ionic bond. Now, let us consider the two atoms A and B. Come to here, an atom A has only one electron and the atom B has 7 electrons in the shell, outermost shell. So, the atom A, it has excess 1 electron, and the atom B, it needs 1 electron to complete the stable octet electronic configuration. So, this atom A transfers 1 electron to B, and atom A, it loses 1 electron, means it forms a positive ion, and atom B, it gains 1 electron, means it forms a negative ion. Can you understand? An atom A, it loses 1 electron, so it forms a positive ion, that is a cation. An atom B, it gains one electron to form an anion. I already told that the force of attraction between the oppositively charged ions that come closer together. So, what is the force between the positively and negatively charged ions? Means electrostatic force of attraction. So, it is called as electrostatic bond or electrovalent bond. Why it is called as electrovalent bond? Because of the valence shell. So, an atom A, it loses one electron. So, A, it forms a positive ion. B, it gains one electron to form an anion, that is a negative ion. So, come to the explanation. Now, you consider the two atoms A and B. An atom A has one electron in excess. An atom B has one electron less than the stable octet. Octet means 8 electrons in the outermost shell. Electronic configuration. If an atom A transfers one electron to an atom B, now then both the atoms will acquire a stable octet electronic configuration. So, as a result, what you understood from the electron transfer means an atom A will become a positive ion, that is cation, and the atom B will become a negative ion. So, here negative ion B minus is there. These oppositively charged ions, plus and minus ions, are held together force of attraction, electrostatic force of attraction, which is called as ionic bond or electrovalent bond. In general, the ionic bond is formed between a metal and a non-metal. For example, metal means Na, sodium, non-metal means Cl. So, they form the compounds containing between the ionic bond, NaCl in between the bond, that is an ionic bond, and are called as ionic compounds. So, NaCl is called as ionic compounds in between Na and Cl. Na is a metal and Cl is a non-metal. In between the bond is called as the ionic bond. So, NaCl, the compound is called as ionic compounds. The elements of group 1, for example, in group 1 sodium, potassium, and group 2 magnesium, calcium, in the periodic table, that is alkali metals and alkaline earth metals, they form ionic compounds when they react with the non-metals, because sodium Na, magnesium Mg, they react with a non-metal Cl to form an ionic compounds, NaCl, MgCl2, AlCl3. So, these compounds are called as ionic compounds when they react with the non-metals. Now, explanation or example, illustration 1 for the formation of ionic bonding in sodium chloride. Sodium means Na, chloride means Cl. The atomic number of sodium has the symbol Na, is atomic number is 11 and its electronic configuration is 2, 8, 1, and here one excess electrons. So, it has one excess electrons to the nearest stable electronic configuration of a noble gas. The noble gas is called as neon. So, the sodium has a tendency to lose this one electron and form its outermost shell and occurring a stable electronic configuration forming a sodium cation. Sodium means Na, cation means plus. When they become Na plus, sodium atom, it loses one electron in the outermost shell and it becomes a sodium cation Na plus. Now, come to the next one, that chlorine. The atomic number of chlorine is 17 and its electronic configuration is 2, 8, 7. Come to here the outermost shell, look at here, it needs only one electron, then only they complete the stable octet electronic configuration. So, they need one electron. So, it has one electron less than the nearest stable electronic configuration of noble gas, that is argon. So, chlorine has a tendency to gain one electron from the sodium atom to acquire a stable octet electronic configuration, and they forming a chloride ion Cl minus. When it becomes Cl minus, chlorine gains one electron to complete the stable octet electronic configuration. So, chloride ion means it gains one electron, and a chloride ion means Cl minus. Then come to the picture, the formation of ionic bond in sodium chloride, NaCl. Sodium means the atom symbol Na, and it has the atomic number 11. And atomic number 11 means the electron number of electrons is also 11. So, how to write the electronic configuration? 2, 8, 1. So, you have to fill the electrons. In the first shell contains 2 electrons, the next shell contains 8 electrons, and the last shell, valence shell, contains only 1 electron. So, they has excess 1 electrons. And come to the next atom, chlorine atom, atomic number 17. Atomic number 17 means the number of electron is also 17. The electronic configuration is 2, 8, 7. So, they need one more electrons to complete the octet electronic configuration. So, now you fill the electronic configuration, electron dot structure. The first shell contains 2 electrons, the second shell contains 8 electrons, and the valence shell or outermost shell contains only 7 electrons. So, they need 1 electron. So, the sodium atom, they transfers 1 electron to chlorine atom. So, sodium atom, it loses 1 electron to form a sodium cation. So, the electronic configuration is 2, 8. And this chlorine atom, it gains 1 electron and to form a chloride anion. It gains only 1 electron. So, they form a chloride anion. Na plus. Why it becomes Na plus? Sodium atom loses 1 electron. So, it forms a sodium cation. Chlorine atom gains 1 electron to form a chloride anion. So, in between the plus and minus oppositively charged ions, the force is called as electrostatic force. The electrostatic force, they holds the ions together to form a compound NaCl, sodium chloride. This is the formation of ionic bond in sodium chloride. Now come to the next one. When an atom of sodium combines with an atom of chlorine, here what happens? An electron is transferred from sodium atom to chlorine atom, and they forming a sodium chloride molecule, NaCl. Here thus both the atoms Na and Cl, they attain a stable octet electronic configuration. So, the outermost shell contains 8 electrons in the outermost shell. So, that should be stable. So, they form a stable octet electronic configuration. This is the formation of sodium chloride. Now, come to the second example, the formation of ionic bond in magnesium chloride, MgCl2. The atomic number of magnesium has the symbol Mg, its atomic number is 12, and the electronic configuration is 2, 8, 2. And this magnesium, it has 2 excess electrons in the outermost shell. So, it has 2 electron excess to the nearest stable electronic configuration of a noble gas, neon. So, this, and here as explained, I already explained a chlorine atom. Chlorine, what is the atomic number of chlorine? The atomic number of chlorine is 17, 2, 8, 17. So, the sodium atom gains 1 electron. So, MgCl2, Cl, how many Cl here? 2 Cl. So, each chlorine atom receives 1 electron from magnesium atoms to form a chloride anion. Can you understand? Atomic number of chlorine is 17. The electronic configuration is 2, 8, 7. So, the formation of ionic bond in magnesium chloride MgCl2, 1 Mg but 2 Cl. Come to the picture, magnesium atom. 12, atomic number 12, electronic configuration 2, 8, 2. First shell contains 2 electron, next second shell contains 8 electron, and the outermost shell contains 2 electrons. Here excess 2 electrons. And come to the chlorine atom, and here first chlorine, second chlorine. Chlorine atom, it has the electronic configuration 2, 8, 7. So, each chlorine atom, they needs one more electrons to complete the stable or octet electronic configuration. So, each chlorine atom, they receives one electron from magnesium atom and they forming a Cl minus. Each chlorine atom, they gains one electron to form a Cl minus. Can you understand? Now come to the magnesium cation. Magnesium, it loses 2 electrons to form Mg2 plus, so magnesium cation. And each chlorine atom gains 1 electron to form Cl minus, Cl minus, Cl minus. So, here 2, 8, 8. So, each atom receives 1 electron from magnesium atom to form a chloride anion. The electronic configuration is 2, 8, 8. Now, look at here, all the 3 atoms, magnesium, chlorine, chlorine, all these 3 atoms, they attain a stable octet electronic configuration. So, they form a bond that in between both the atoms, that is a ionic bond in between the positively charged ions. Electrostatic force of attraction is come closer, and they forming a bond here in between magnesium and chloride, that is ionic bond, and this compound is called as ionic compound of magnesium chloride MgCl2. So, here 2 chlorine atoms will gain 2 electrons lost by the magnesium atom, they forming a magnesium chloride molecule MgCl2. So, magnesium has a tendency to lose 2 electrons from its outermost shell and here and acquire a stable electronic configuration, and they forming a magnesium cation. Mg2 plus. Mg2 plus. Magnesium loses 2 electrons to form Mg2 plus, and each chlorine atoms gain 1 electrons to form a chloride anion. So, 2 Cl minus. All these 3 atoms, they attain a stable octet electronic configuration, and the bond formation is an ionic bond, and this formation of ionic bond in magnesium chloride, they form a molecule MgCl2. Now, what are the characteristics of ionic compounds? First one, physical states. Ionic compounds are solids at room temperature. The second point, electrical conductivity. In molten state only, it conducts electrical conductivity. The third point, ionic compounds have high melting and boiling point. Then solubility. Ionic compound, I will tell one example of ionic compound, NaCl, MgCl2, AlCl3. So, these ionic compounds are soluble in polar solvents. What is a polar solvent? Water. So, these compounds are soluble in water, polar solvents, and it is insoluble in non-polar solvents. Benzene, C6H6, carbon tetrachloride, CCl4, toluene. So, it is insoluble in non-polar solvents. So, it is ionic compounds are soluble in water, that is a polar solvent. Ionic compounds have high density and it's very hard, and it is highly brittleness. It is easily breakable. And these ionic compounds, they undergo ionic reactions. The ionic reactions are rapid. Rapid means fast and also instantaneous. It is It is instantaneous. So these are the characteristics of ionic compounds. Yes, now come to the assignment. What is ionic or electrovalent bond? Second one, explain the formation of ionic bond in MgCl2. What are the third one? What are the characteristics of ionic compounds? These three questions you have to learn and write one time. Okay students, thank you.